In this video, we are going to discuss angle measure as well as what makes up an angle. And so to start talking about angles, we need to think about how they are made, what components they have. So we need to talk about a geometric figure in particular called a ray. So starting off with the formal definition, a geometric figure is a ray if and only if, I'll go ahead and bold that, it's a ray if and only if it is a subset of a line with exactly one endpoint. So thinking about those words again, if and only if means that we can treat this both forward and backwards. A figure is a ray as long as it has exactly one endpoint and is a subset of a line. Also, if we have a subset of a line with just one endpoint, it is a ray, not something like a line segment. Okay. The other part to note of this is what subset of a line is. We should know that a line goes on forever in two directions. A ray is only going to go on in just one direction. So it's part of a line, except we are only going to continue in one direction. So here's a ray below. Let's go ahead and make that arrow a little more obvious. So we have a starting point. We can give that point a name. Maybe we call it A. Maybe we give the next point the name B. When we look at this ray, we can see it has an initial point starting at A, and then it continues on from A, going through the point B, and forever onward in that direction. So the way that we name this figure is simply by using 2 points on the ray. One of those points has to be your starting point. So in this case, we can call this ray AB, and to show which way the ray is going, we simply draw that figure above and put the arrow in the proper direction. So when you draw this part of the name, show the initial point above the letter that it corresponds to in the picture, and show the arrow going through the other point that it did. So if this ray starts at A and goes through point B, then we need to start at A and go through B and show the arrow going in that direction. Now with rays, we do have some different setups that can occur. One thing that can happen is when you have two rays that are considered a case of opposite rays. So two rays for us are considered opposite rays if and only if they have a few properties. They have to have the same vertex, they have to be collinear, and they have to be continuous in opposite directions. So if one goes east, the other has to go west. Okay, so a case of opposite rays would be down here. I'm going to go ahead and put some letters in this picture. So in this diagram, we have points D, E, and F, and there are a couple of rays that we can talk about here that would be considered opposite rays. We have a ray that we could talk about that starts at E and goes through point D. So I'll show that ray in green. We also have another ray we could discuss, I'll show in purple, that starts at E and goes through F. Now you might be thinking the diagram was just showing a straight line. Well, you're right if that's the case. Opposite rays essentially just create a straight line. I forgot to put rays up here. So opposite pair of rays are opposite rays. So when we have two opposite rays, what we need to know is that we are really just creating a straight line, which is going to help us out with some angle properties that we'll get to. But for now, looking at this diagram, what we can say is that segment or ray ED and ray EF are opposite rays. And so because of that, we are creating a straight line. Okay, so what we're going to get down into in these notes is what exactly is an angle. So a geometric figure is an angle. And we have a symbol for that as well. So the symbol for this, it kind of looks like a less than sign. And some textbooks use that notation. We're going to show that notation with an arc going through it. So what we need to start practicing is when we see this particular symbol, we will read the word angle in our heads. So when we see that symbol, we'll say the word angle either out loud or in our heads as we read. But as far as a figure being an angle, it is an angle if and only if it consists of two rays with a common endpoint. So a case of an angle would be down here. You have a ray that starts at R going in this direction, and you have another ray that starts at R going in a different direction. And when we have that, we have this opening between your two rays, and that is what we're talking about when we're talking about our angle and its measure. So we have what's called an angle here. Essentially, it has two sides. The two sides have a common vertex, a common endpoint. So for naming this angle, we want to be able to talk about its different properties. So to start, it does have a vertex. And in our particular diagram, the vertex is point R. And remember, to name points, we just use a capital letter. And the indication is this represents point R. We have two sides, and the sides are rays. And so let's see what rays that we have. This ray here starts at R and goes through C. So we'll call that ray RC. And the other ray also starts at R and goes through L. So we'll call that ray RL. So those are some different parts of the angle. Something else we need to talk about is how do you refer to this angle. So if you look at a picture and you want to talk about it with someone else, how could you refer to it? There are a couple ways. One way is to use 3 points that are traced with the sides of the angle. So you notice with this angle that I've shown with these blue rays, if I start at this point here, C, and I trace along the line to the corner, the vertex, and over across the other side, I'd be tracing from C to R to L. So when I talk about angle CRL, that would be the angle that gets traced by starting at C, going to R, and then through L afterwards. So that is one way we can name this angle. So we'll just put the angle symbol down and put CRL afterwards. Now you might also notice we could go in the opposite order. We could start at L, go to R, and then through C, and we are tracing out the same sides. Start at L, go through R, and then through C. Once again, you are tracing the sides of the angle. So that is another valid way to name this. So using 3 letters is pretty common. Notice these are just reversed order from each other, naming the same picture. If we have a case where there's an angle with just one vertex, if there's only one angle at our vertex, so the vertex of this angle is R, and it doesn't appear that there are any other angles that we can trace out. In a case like this, it is okay to name the angle by its vertex. So we can also call this angle R. And one last way is if you see a number written inside, this is not doesn't have anything to do with the size of the angle. It's just when we start having multiple angles we talk about, we can number them as 1, 2, 3, 4, 5, and so on. So one last way we can name this particular angle is by looking at that number in the corner and refer to it that way. So we can also name this angle as angle 1. And that is one of the more common ways. I would say the least common way we're going to name an angle is just by using one letter. You're either going to see it named as a number written in the corner or by using 3 points that are on the sides. So then we have what's called the interior and the exterior. The interior is the inside of an angle. So if you look at this angle, here are the corners, or here are the sides of our angle. If we were to look at the space between our two sides, this is considered the interior. So for this particular diagram, the interior is located, the point M is located in the interior. So there is a point in our interior, and the exterior would be the opposite. It would be on the outside. So any points not within the interior and not on the sides of your angle. So that would be a case of point A. Point A would be in the exterior of your angle. Okay, so let's look at another case down here in this diagram that gets a little more complex. We see a few angles in this picture. So it looks like some of the things I'm asking you for got cut off when I was in the reformatting of the document. First thing I want to do is look at this picture and talk about the sides of angle 1. So I'm going to go ahead and fix that over here. When we talk about the sides of angle 1, what you want to do is go find that angle. So here we see that there's a few angles numbered. 1 is up here in this corner. So let's find that corner point. And then from that point, we're essentially just going to trace outward for the two sides that have 1 in between them. So if we trace these two sides, this is the angle that has 1 in the corner. So this is considered angle 1. And the two sides would be the rays that start at point D. So we have ray DA and ray DB. So just remember that rays are what make up the sides of our angles. The vertex question, that is supposed to be for the vertex of angle 3. So let's fill that in as well. So to find this, we need to find where the 3 is located and figure out what corner it is located in. So here is the corner at angle 3, and you could trace the sides of that angle to where 3 is in between these two sides. And we see that 3 is at the corner with point C. So C would be the corner of this angle. It would be the turning point where the two sides of the angle meet up. That is our vertex for this angle. And to show a point, we just write the capital letter. So the vertex of angle 3 is point C. And the last thing to practice here is two other names for angle ABD. So let's practice different ways that we've talked about naming angles. So angle ABD, let's go find that one. So what we can do is take our pencil and trace along the letters that are listed in the same order that they're listed. So angle ABD, we can do start at point A, then connect over to B, and then connect through point D. So you can see that we have one side of our angle going this way from B to D. That means the other side of your angle would be going from B through A. So we can finish tracing out that side here. So this would be angle ABD. And when we look at this angle, we do see that there is a number that was put there to indicate it. So we can call this angle 2. That is another option for us. So just put that angle symbol down with a 2 afterwards. Another easy way to do this would be just to reverse the order of the letters that are there. Because if you trace from D to B and then through A, you're just tracing out the same sides again. So we are practicing this not because you need to list the names of angles a bunch of times. You don't need to name an angle in all kinds of ways. What's more important is that you understand that all of these are valid ways to name that angle. They're all describing the same thing. Notice as well, I'm not using angle B to name this angle. I'm not just going to use the vertex. And the reason for that is this diagram is more complex. So if you look at point B, there are actually a few other angles that we could talk about. We have an angle here that we could talk about. It's not listed, but we could call it angle 4 that's in this corner. We have an angle in this corner that we could call angle 5 maybe, and we have another angle in this corner that we could call angle 6. Um, and so because there are so many different angles shown with a corner at B, they all have the same corner point. We don't want to just name this as angle B because that would be a little confusing as to which angle we're talking about. So the best options here, use the number that's written in the corner or use 3 points on the sides of the angle.